chapter 2, we're going to get into.
Is it recording?
Yep, it's recording right now. So, in chapter 2, now you can go say hi, class. So, in chapter 2, as it says here in 2.1, we're going to talk about describing the location in a distribution. But later on in chapter 2, we're going to get into special types of distributions, and specifically the normal curve and finding, locations within a normal curve. So to start us off, we have this concept of percentile. Percentile is basically, you locate where your data point is, and you're describing what percentage of data points are below that score. The key thing is, it's less than it, okay? So you take the number of scores below your score and divide it by the total number of scores. Very basic, very simple. Something, again, percentile, we did a little bit in Algebra 2. So for instance here, in the example, just to give you some practice, below is a stem plot. A graph that we've seen before in Chapter 1 that contains the score of all 25 students in Mr. Joachim's third block AP Stats class. How does he get a class size of 25? I don't know. So, it says use the scores on Mr. Joachim's third block AP Stats class to find the percentiles for the following students. Gannon, who earned a 72.
Wow, I wonder what that is.
Okay. So there's 72. How many scores are below 72? One. One score below 72 out of 25. That's 4%. Okay. So Gannon's score is in the 4th percentile. Sophia, who earned a 93. Okay. Here's Sophia. How many scores are below Sophia's score?
24.
24. So 24 out of 25 is 96%. So Sophia score is in the 96th percentile. All right, the two students that earned a score of 80. So this is the fun part, because some people go, well, what happens if the score repeats? Well, here's my two 80s. I always have to look at the scores that are below. So I don't count one of the scores of 80 in my percentile. So 2, 4, 6, 7, 8, 9, 10, 11, 12. So 12 out of 25, I believe, is 48%, 0.48. So these two students are in the 48th percentile. Percentiles are great because you can start to compare your scores to others, okay? Especially in a large group. Okay? Many times where you start to see percentiles, when you were young and you were a kid, little kid going to the doctor, you usually get your height and weight, and they tell you what percentile you would be in for kids your age, boys or girls like age 4 or 5. I took Sophia to her doctor appointment for her 5th. When she was 5, they gave her her height and weight, and they gave me her percentiles. So you can kind of start to tell, ooh, she's tall for her age group, or she's, very heavy for her age group, or she's very light. Okay? So percentiles are a great way to compare yourselves to other people. Now, sorry, I'm going to skip here and come back because I'm just having a little technical issue there. Now, another way percentiles sometimes can be presented is in what's called cumulative relative frequency graphs. How these graphs work is you have the variable on the x-axis, while the cumulative percentiles are basically on the y-axis. Your graph almost kind of looks like a timeline or a plot. As you increase your scores, your graph will increase up to 100%. Okay? Where you contain basically all the scores. Okay? So like for instance here we have call length times in minutes and their relative frequency. So we can figure out what percentage of the calls were at certain time frames. So for instance, in question A here, reading this graph, it says at about what percent of calls lasted less than 30 minutes. So what I could do here is look at 30 minutes, go to my graph, go straight across, and estimate about what percentage of the calls were, or that lasted 30 minutes or less, because that's what that value actually represents. Okay, so it's somewhere between 60 and 80. It's about maybe a quarter of the way up.
67.
Okay, 65%. If you said 67 or 63, I'd be okay with that. Maybe even 62, depending on how well you drew the line. I want like 70, I want like 60. So if this is less than 30 minutes, how many lasted 30 minutes or more? Okay.
35.
35, 100 minus 35, or, I'm sorry, 65, I'm already doing the math, or about 35%. If you said 62 here, then this better be 38. So now, question B, let me move this up just a tiny bit. It's going to jump up way too high, but I can do that. So, part B says, estimate Q1, Q3, and the interquartile range of this distribution. Q1 is what percentile?
25.
And Q3 is? So what I have to do is work backwards. Here I was taking a call length, finding the percentile or percentage. Here I have the percentage. I need to figure out the call length. So I'm going to estimate 25. So here's 25. Do the best I can, going straight across, going straight down. Oh, I don't know if I went perfectly straight down. So Q1, I'll tell you right now, I'd say it's somewhere either 12 or 13. Let's just pick one and say about 13. Q3, 75%. Going as best I can straight across, straight down. Looks like about 32 minutes. Q3 is about 32. So then my IQR, 32 minus 13 is 19 minutes. So I could say something to the extent of the middle 50% of calls have a range of 19 minutes. All right, let's flip to the second page. Standardized value. One of the things that we want to be able to do is to start to be able to compare different scores relative to certain values. A standardized value basically compares any score in a distribution to its mean and compares it to not only to its mean, but ask yourself how many standard deviations, hence the word standardize, how many standard deviation your score is going to be away from the mean. Okay? So how you calculate out a standardized score, otherwise known as a z-score, get to know that, love it, make it your best friend, because we will do z-scores a lot in this course. What z represents is you're going to take your score, and that's what x represents. You're going to subtract the mean from it. And this symbol is technically population mean. It's the Greek letter mu. And divide it by the standard deviation sigma, which is population standard deviation. Okay. Now, if we have a set of scores that represents the entire population, we can then our sample mean and standard deviation become our population standard deviation. So what happens here is we're going to have a set of scores, and here's our mean. If our score is above the mean, our z-score will be positive. If our score is below the mean, our z-score is simply just going to be negative. Thank you. Reese.
I'll explain that for you.
You do?
Yeah.
Oh. Unless if it's like a detention pass.
No, I think they're funny to get.
So now, as noticed here, it says positive z-scores greater than the mean, negative z-scores less than the mean. The interpretation of a z-score, it basically tells you how many standard deviation, okay, your score is away from the mean. How many standard deviations you're either above the mean or below the mean. So, to give you a practice of this, last example problem of today says use the information from Mr. Joachim's third-hour block class to find the standardized scores, z-scores, for each student. Interpret each value in the context of the problem. So, in order to do this, I actually have to calculate out two values. I need to figure out what's the mean of Mr. Joachim's third block class and what's the standard deviation. So, to get that, if you trust me,
I trust you.
I already entered in the data points from Mr. Joachim's class in list 3, just to save a little bit of time. But if you wanted to follow along and do it, go ahead and enter in those 25 scores in list 3. However, I am going to continue on. So those of you watching this video, pause it, enter in the scores, and start it up again.
I like that.
You're welcome. So now, all you have to do is, again, stat calculate, one variable statistics, list 3. Because that's where I have them. If you have them in list 1, L1, or you can just hit enter. Cool. So, the average test score was 80, the standard deviation 6.07. So that's where I'm getting these two values, 80, 6.07. So now, let's figure out Gannon's z-score. Z, his score was 72. The mean was 80, standard deviation 6.07. Oh, Gannon. So, 72 minus 80, if you're going to do it on your calculator, this is just order of operation stuff. You can't type it all in at once unless you put the 72 minus 80 in parentheses. So I just go ahead and hit enter. I get negative 8 divided by 6.07. I get negative 1.3179 ... I round z-scores to 2 decimal places. There's a reason for that, because when we start doing normal curves and we use a table, they're all rounded to 2 decimal places. So negative 1.32. So, what does that mean? What does negative 1.32 represent? Well, we would say Gannon's score of 72 is 1.32 standard deviations below, that's the key, since it's negative, it's below the mean of 80. The mean is our average, so we know that he's scoring 1.32 standard deviations below that. I do the same thing for Sophia. Sophia had a 93. Oh, way to go, Sophia. 93 minus 80 divided by 6.07. It's going to be 2 point something. So 93 minus 80, some of you could do that in your head and get 13, divided by, 6.07. 2.14. So we would say Sophia's score of 93 is 2.14 standard deviations above the mean of 80. I suppose I could say 80 points, since I know the context is points. So knowing how to calculate out a z-score and knowing what it represents is going to be very important in Chapter 2. We will be doing lots of z-scores, because later on we'll be using z-scores to help us calculate out certain types of percentiles, proportions, and percents. All right, that ends your notes for 2.1.